Welcome again, guys, to G Squared Academy, where excellence is epitomized. So as I said, I'll be answering questions about difficult CSEC chemistry questions for the most part. If there are other chemistry questions, whether it be CAPE or IB or AP, then I'm happy to help with those as well. So in this question, what we have is, this is an organic question. It says an unknown organic compound, which is called X, has the molecular formula C3H6O2. All right, so we know the molecular formula of the species. We recognize that it contains 2 oxygens here, which tells us that it's not an alkane, alkene, or alkyne, because those species do not contain oxygen. Those are hydrocarbons. It says also that compound X reacts with sodium carbonate to produce a gas that turns lime water milky. Now what we know is that sodium carbonate reacts with acids. So we have some kind of inkling already that this is an acid. Now, which gas turns lime water milky? That gas is actually carbon dioxide. So just looking at this, you should be getting some clues as to what X is. Now, you would have to tap back into your prerequisite knowledge on acids, bases, and salts to remember that acids react with carbonates to produce salt, water, and carbon dioxide. And of course, the test for carbon dioxide, lime water is used and it turns it cloudy or milky. Yeah? It says now when X is warmed with ethanol, so X is reacting with ethanol and a few drops of concentrated sulfuric acid, a sweet smelling liquid is formed. And of course, your teacher would have told you when looking at organic that sweet smelling organic species are usually going to be esters. So from this statement, we have gotten quite a bit of information. We have gotten that X, based on its formula, is not a hydrocarbon, so it's not an alkane, not an alkene or an alkyne, right? And it would not be an alcohol too, unless it's a diol. And then also, when it reacts with sodium carbonate, which reacts with acids, it produces a gas. A gas is produced that turns lime water, which is used to test for carbon dioxide, milky. So it gave a positive test with the lime water. It also mentions that when it reacts with ethanol, ethanol is a type of alcohol, or is an example of an alcohol, with sulfuric acid, then you get a sweet smelling compound, which we know, generally speaking, sweet smelling compounds, we call those esters. So, what is your examiner asking you to do? Your examiner is now saying, identify the homologous series to which X belongs. And from our discourse so far, you should recognize that X is an acid. So we can say that this is an acid, yeah? It's a carboxylic acid. I'm just writing acid for short, but it is a carboxylic acid. Now, it says that we should draw the structural formula of X. So I'm just going to scroll down a little bit so we can draw that there. So X is actually this species. So we just want to make sure that we have the correct structure that matches the molecular formula. So our molecular formula has 3 carbons. So we have 1, 2, 3 carbons. It has 6 hydrogens, so we have 1, 2, 3, 4, 5, 6 hydrogens, and we have 2 oxygens, 1, 2. So our structure definitely matches our molecular formula there. Then it asks us to write a balanced chemical equation for the reaction of X with sodium carbonate. So let's do that now. All right, there you go. So now we have the balanced equation. Now, the question is, how did we come up with this equation? And I think that is where the challenge is going to be for most of our students. Now, the thing is that this is our acid. Now, you must remember that when an acid reacts with a salt, in this case sodium carbonate, or with a carbonate, then a salt is formed. So you're thinking, okay, an acid reacts with a salt to produce a salt. So let's just forget let's not call the sodium carbonate a salt right now and just call it a carbonate for now. Okay, now so our acid reacts with the carbonate to produce a salt and water. But so we need to remember how our salt is formed. A salt is formed when a metal, in this case sodium, takes the place of a proton or a hydrogen, an acidic hydrogen, in an acid. Now in our acid here, our proton or acidic hydrogen is this hydrogen right here. There it is right there. So what's going to happen is that this sodium is going to take the place of this hydrogen. So it's going to replace it. And that is how we got this salt right here, C3H5O2. So 1, 2, 3 plus these 1, 2, 3, 4, 5 hydrogens still remain and the O2 remains. So nothing else happens. The sodium simply takes the place of the oxygen, the hydrogen, replacing it there in the structure. Now when the sodium takes its place, the hydrogen is gonna interact with the carbonate ion, and that is where you're gonna get your carbon dioxide and your water remaining. Now after all of that is done, you need to balance your equation. So you had 2 sodiums on the left, so you must have 2 sodiums on the right. So since 1 hydrogen is present here, only 1 sodium needed to replace that hydrogen. So replace it with 1. But to balance it out, we put a 2 in front of the entire formula of the salt, this propanoate salt. Yeah, and so because you have 2 of these, you need to have 2 of these over here as well. So let's just check to make sure that our equation is actually completely balanced. So this is 6 hydrogens, 2 times 3, 6, and we need to have 6 over here, so that's 2 times 3, 6 as well. We have 2 times 6, which is 12 hydrogens. Over here we have 2 times 5, which is 10, plus 2, 12. So we have 12 hydrogens there. Now over here we have 2 times 2, 4 oxygens plus 3 more oxygens there, so that's 7. And on the product side we have 2 times 2, which is 4, plus 1, 5, plus 2, 7 oxygens. So this indeed is our balanced equation for the reaction between this species, which is propanoic acid, and sodium carbonate. The critical thing to remember, and I repeat it, the critical thing to remember is that an acid reacts with a carbonate to produce a salt and water and also carbon dioxide. Now, a salt is formed when a metal or the ammonium ion, and in this case our metal is sodium, replaces the hydrogen, the acidic hydrogen or the protonic hydrogen in an acid. And in this case, this hydrogen out here is the proton hydrogen, and this hydrogen will be replaced by 1 sodium. So we replace it there and we end up with this species down here. And of course we need to balance the number of hydrogens and the number of sodiums, carbons, etc. That's why we place the 2 in front of the formula there. So I hope you guys find this video helpful. If there's anything that you want to clarify about the video, just let me know. Write a message in the comments and let me know. Also, let me know which other questions you find difficult, and then I will look at those for you as well, helping us as we prepare for our exam. So this is G Squared Academy, where excellence is epitomized. All the best.